Good day. So for this video, we will be discussing the applications of the derivative of trigonometric functions. So let's start with our first example. So this is under tangents and normals. So find the equations of the tangent and normal to the function at the given point. So we have here y is equal to negative 2 cotangent 2x at pi over 4 and 0. Okay? So as you can see, we have our given function. So the function is trigonometric, and as you can see, the point here pi over 4 0. So the pi over 4 here is in radians. So therefore, in all of our calculations, so we will use the we will set in mind that the angles, okay, are in radians. Okay, so to solve for the slope of the tangent, so slope of tangent which is m sub t. Okay, so we solve that by getting the first derivative, right? So this is equal to dy over dx at this point, okay, at x is equal to pi over 4. Okay, so deriving this, so you have y is equal to negative 2 cotangent of 2x. Okay, so what we need is the derivative of y with respect to x. Okay, so deriving this, okay, so the derivative with respect to x of negative 2 cotangent of 2x. Okay, so we have a numerical coefficient, so we can take that out of the derivative sign. So we'll have negative 2 derivative with respect to x of cotangent 2x. Okay, so recalling the formula for the derivative of the cotangent, so the derivative of cotangent of u, so recall that the derivative with respect to x of cotangent of u is equal to negative cosecant squared of u times du over dx. So therefore, this will become the derivative of cotangent of 2x is negative cosecant squared of 2x. Multiplied by du over dx, so the derivative of 2x. So the derivative of 2x with respect to x is 2. Okay, so therefore, dy over dx is equal to negative 4. Sorry, it's positive already. So positive 4 cosecant squared of 2x. Okay, so therefore at x is equal to, so what's the point? X is equal to pi over 4. Then we will have the slope of the tangent line is equal to 4 cosecant squared of 2 times pi over 4. Right? So it will become 4 cosecant squared of pi over 2. Okay? So evaluate this. So cosecant squared of pi over 2, so that is equal to 4 multiplied by, since cosecant is the reciprocal of sine, so it's 1 over sine squared of pi over 2. Okay, so since the sine of pi over 2, so recall your trigonometry, the sine of pi over 2 is 90 degrees. So sine of 90 degrees is equal to 1, and then squared, so therefore it's equal to 4 times 1 over 1 squared. Okay, so because sine of pi over 2 is equal to 1. So therefore, the slope of the tangent is equal to 4. Okay? So, also, since we are going to solve for the normal, so the slope of the normal is equal to negative reciprocal of the slope of the tangent. So therefore, the slope of the normal is negative 1/4. Okay? So, to solve for the lines, the equation of the lines, tangent, sorry. So we will use the point slope form. So where we have y minus y1 is equal to m times x minus x1. Okay. So y minus, so our y1, our point is 0 for y and x pi over 4. So y minus 0 is equal to, slope of the tangent is 4 times x is pi over 4. Okay. So pi over, sorry. This is x minus pi over 4. Okay, so distributing 4 and then simplifying, so this will become y is equal to 4x minus pi. Okay, or you can express it in general form, so this will become 4x minus y minus pi is equal to 0. Okay, so this is the equation of the tangent. So similarly, you can also do the slope, you can also do the equation of the normal. So all you need to do is replace this with the slope of the normal, which is negative 1/4. Okay, so let's do that. So what is that? Y minus y1 is equal to m times x minus x1. So y minus 0 is equal to, slope of the normal is negative 1/4, x minus pi over 4. Okay, so this will become y is equal to negative 1/4 x minus pi over 4. So we can cross multiply 4 on the other side, so it will become 4y is equal to negative x plus pi over 4. Okay, so transposing, so it will become x plus 4y minus pi over 4 is equal to 0. Or if you don't want any denominator, so you can multiply both sides of the equation by 4, so that you will get 4x plus 16y minus pi is equal to 0. Okay, so that is still the same line. Okay, that is the normal line. Okay, so for our second example, so we have a worded problem. A wall 5 feet high is 8 feet from a house. So find the length of the shortest ladder that will reach the house when one end rests on the ground outside the wall. Okay, so we have an 8 feet high wall, which is 8 feet from a house. So say this is our house. and we have a 10 feet wall, sorry. So let's say this wall is 10 feet high and it is 8 feet from a house. So it's 10 feet and then we have here 8 feet. Okay. So we're asked to find the shortest ladder. So let's say this is our ladder. Okay, with the length L. Okay. So what is the length, okay, of that shortest ladder? Okay. So we will solve this using trigonometric functions. So as you can see, obviously we have here a right triangle. Okay, so forming with the legs corresponding to the ground and the house, and also the wall. Okay, so let's say this is our angle theta. Okay, and let's say the distance, this distance until here is x. Okay, so we want to maximize L. Okay, so using the trigonometric function, so we will maximize that length, okay, that L. So using this triangle, okay, the larger one, so we can say that we are given here with the adjacent side and the length and the hypotenuse as the length as the hypotenuse. So maybe we can use cosine. Okay, so solution. So we can say that cosine of theta is equal to adjacent over hypotenuse. So the adjacent side is, we have x plus 8 over L. Okay, or if we try to solve for L, L is equal to x plus 8 over cosine of theta. Okay, so this is now our objective function, and we want to minimize, okay, L. But as you can see, so our function is in terms of two variables, x and theta. We want to express this in terms of one variable only. Okay, so as you can see from the smaller triangle, okay, we can also get a relationship using the trigonometric function. So we have the opposite side and we have the adjacent side. Okay, so maybe we can use tangent. So from here, okay, so from the smaller triangle, so this is from the larger triangle. So from the smaller, triangle, so we can say that tangent of theta is equal to opposite over adjacent, so 10 over x. Okay, so cross multiplying, so x is equal to 10 over tangent of theta. And since 1 over tangent theta is equal to cotangent theta, then we can say that x is equal to 10 cotangent of theta. Okay, so if we substitute this, we substitute x is equal to 10 cotangent theta in the x here, so therefore it will become 10 cotangent theta plus 8 over cosine of theta. Okay, so as you can see, our L now is a function of theta only. Okay, so we have eliminated x. So from here, we can already differentiate, but I think it's easier if we simplify first. So distributing cosine theta, so 10 cotangent theta over cosine theta plus 8 over cosine theta. Since we know that cotangent theta is equal to cosine over sine, so therefore L is equal to 10 times cosine theta over sine theta whole over cosine theta plus 8 over cosine theta is since 1 over cosine theta is equal to secant theta, then it's 8 secant theta. So as you can observe here, in the first term, we can cancel out cosine theta. What will remain is 10 over sine theta, for which 1 over sine theta is equal to cosecant theta. So therefore, L is equal to 10 cosecant theta plus 8 secant theta. Okay? Okay, so from there, derive L with respect to theta. So dL over d theta is equal to, so deriving this, so this will become, we have a numerical coefficient of 10. Derivative of cosecant theta is negative cosecant theta cotangent theta multiplied by the derivative of theta with respect to theta, so that is 1 plus 8. Derivative of secant theta is secant theta tangent theta, and then derivative of theta with respect to theta, that is 1. Okay, so to maximize or minimize, we must set the derivative to 0. Okay, so setting the derivative to 0, so we will have equal to 0. Okay, so we can also transpose 1 to the other side. Okay, so it will become 8 secant theta tangent theta is equal to 10 cosecant theta cotangent theta. Okay, so to see it better, it's better to express all in terms of sines and cosines. So 8 secant theta is 1 over cosine theta. Tangent theta is sine theta over cosine theta is equal to 10. Cosecant theta is 1 over sine theta times cotangent theta is cosine theta over sine theta. Okay, so as you can see, to eliminate the denominators, so we can multiply both sides of the equation by sine squared theta cosine squared theta. Multiply by sine squared theta cosine squared theta. On the other side, multiply it also by sine squared theta and cosine squared theta. Okay, so what will remain here is, we can cancel out cosine squared theta. Okay, So what will remain is 8 sine cube theta is equal to, on the other side, we can eliminate sine squared. So what will remain is 10 cosecant cube. Cosine cube. Okay. So, we can divide both sides by 8 cosine cube theta. Okay, so that what will remain is sine cube theta over cosine cube theta. It's equal to 10 over 8, so that is 5 over 4. Okay, or sine cube theta over cosine cube theta, that is also equal to tangent cube of theta. Is equal to 5 over 4. Taking the cube root of both sides, so we will have tangent theta is equal to cube root of 5 over 4. Okay, so solving for theta, so theta now will be arctan of cube root of 5 over 4. Okay, so using our calculators, so this will be arctan of cube root of 5 over 4. Okay, so that is 48.19. Okay, let me check again. Arctan of cube root of 5 over 4. Okay, so that was different again. Arctan of the cube root of 5 divided by 4. Okay, so it's around 17.13, or if you wanted to be exact, you can also use that. 47 degrees, 7 minutes, and 44.05 seconds. 47 degrees, 7 minutes, and 44.05 seconds, or you can also use 44 point 47.13. So never mind this one. Okay, so therefore that is the value of theta, okay, at the minimum length. Okay, so therefore from our equation for length, it is that L cosecant theta plus 8 secant theta. You can also use this one. So let's copy that. So 10 cosecant theta plus 8 secant theta. Okay, so since we know that cosecant theta is the reciprocal of sine, so therefore it's 10 over sine theta plus 8 over cosine of theta. So substituting this angle, so 10 over sine of 47 degrees, 7 minutes, 44.05 seconds, plus 8 over cosine of 47 degrees, 7 minutes, and 44.05 seconds. So we will have, using our calculator, so we will have 10 over sine of 47 degrees, 7 minutes, 7 minutes, 44.05 seconds plus 8 over cosine of 47 degrees, 7 minutes, and 44.05 seconds. So we'll have 25.4. So what was the unit? So that was in feet. Okay? So that's how you use the trigonometric functions, okay, in maxima and minima, okay, problem solving. Okay, so that's it